Welcome and bienvenidos to the problem section on additional identities. And I figure I'm just going to do a few problems instead of a lecture. There are some new identities in here, product to some formulas, some to product formulas, but it's just like before, just applying them and looking at them and seeing which identity do I need. And then some other additional identities. They actually start out with some strange problems that we may not have encountered. So let me go down here. And here we have cosine to inverse cosine of x. And we're supposed to write this in terms of x only. Wow, that's going to be interesting. Well, I made a drawing here on the side that shows that, of course, for the cosine, the adjacent is x and the hypotenuse is 1. I forgot to draw in the angle theta, but we would recognize that, well, that's the angle theta here. So the inverse cosine of x over 1 is, of course, the angle theta. So I'm going to write cosine 2 theta. Cosine 2 theta. And then, of course, as a Greek letter. Now I have the angle theta here, and I have a cosine 2 theta. Well, at this point here, I'll be trying to figure out some kind of identity, and conveniently, I have copied myself already double angle identities. I did that beforehand because I knew that I would be coming up with a double angle identity. Which ones do I choose? I'm sorry, which one do I choose? I might as well choose the second one here because I already know something about cosine A, but I don't know much about sine A here. So I'm going to use the second one, which is going to be 2 cosine square A, or I guess theta in this case, minus 1. So that's a Greek letter, and that's a square. So there we go. What do I come up with now? Well, cosine theta I have here. Theta is this one here. What's the cosine of theta? Well, that's x over 1. So I'm going to have 2x, and then because this one here is squared, I also have a square there. So I'm going to take 2x squared minus 1, and we're indeed done. I may want to check that with a checking value on the graphing calculator, and I'll do that in just a moment. The second example looks kind of the same or really similar. The inverse sine of x is in here, and so if we have the angle theta here, then we, of course, we have sine of theta equals x over 1. So the inverse sine of x is theta. So it really kind of looks similar to this one here. Sine 2 theta. It looks like I need to figure out another, cosine. Oops. Cosine 2 theta. Which double angle identity will I be using? Well, the third one, because I know something about the sine x in this case, or sine theta in this case, so I'll be using 1 minus sine squared theta. Let's see, I think I'll just copy this one here. There we go. Let's see, I missed a 2. There's 2. And here I know sine theta right here, of course, is x over 1. So I'm simply going to come up with 1 minus 2x squared. And I keep that in mind as I go to the graphing calculator that this is what I was supposed to come up with. Okay, let's go over there. Okay, what we had at first, for the first one, was cosine of 2 inverse cosine. And this time around, I may want to be in radians. So I'm going to check my mode. Well, better be in radians. Plug in any number, for example, 0.5 radians, which, as I said, I want to said long ago, I want to avoid special angles. 0.5 radians, this roughly is 1/6 of pi, so a little bit less than 30 degrees. I hit enter, and let's see what we come up with. Okay, negative 0.5. That's interesting. Okay, so now I'm going to plug it in. 2 times 0.5 squared minus 1. Oh, okay, I see. That 0.5 here actually was not radians. That was actually the answer, which means I'm going to come up with 30 degrees. Oh well, and I come up with negative 0.5. I may want to do that again in order to avoid a special angle, so I'm going to do this and plug in a 0.4 instead, which should put me somewhere around a little bit less than 60 degrees times 2 is 120, a little bit less than, no, a little bit less than 120 degrees, so negative point something, yeah, negative 0.68, and then I'm going to do this again here. I said I want to avoid the special angles. 2 times 0.4 squared minus 1, and we come up with a nice rational number because our end result is a nice 2x squared minus 1. Okay, I'm going to make a screenshot of this here so I won't forget. And the other one was cosine of 2 inverse sine of 0.3. Example, come up with 0.82, and then I have 1 minus 2 times 0.3 squared, and that of course is the same. Okay, let's go back to the problem section. So I'll be inserting these later here. Okay, write as a sum or a difference. And I didn't copy the product to sum and sum to product formulas in here, so look them up in your book. I'm just going to check them here quickly on the internet where I found a website. So let's see. For example, here it says that, let's see what kind of problem that we have. Sine, cosine. So I'm going to look at the last. Sine cosine equals 1/2 times sine x plus y plus sine x minus y, and that's how I'll be writing it. I hope that I'll remember that when I get back. And for you, I just like you to look wherever you find the identities in your book. So it's going to be 10 times, and then it's sine, cosine. So I'm looking that up. 1/2. They all have that in common. I might as well put a times in front of that. And a times right here, and then a parentheses. And then it says sine a plus b. So it's going to be sine 8x. And it's going to be plus sine a minus b. So it's going to be sine 2x. And then, of course, I can write the front here as simply 5, but the rest stays the same. There's no way I can combine sine 8x and sine 2x. There is no such identity for that one. This one here comes out to, well, 10 of course, and then they all have times 1/2 in common, so I'm just going to drag this along here. All these product to sum formulas, and sine goes with cosine a minus b minus cosine a plus b. So I'm going to put in here cosine a minus b, which is 2x, and then we have minus cosine of a plus b, so we have cosine 8x, parentheses, and again, all I'm going to do in the next line is 10 times 1/2, of course, is 5, parentheses, and there's nothing more we can do with this one. Right as a product here, this is what's called a sum to product formula. So I'm going to go to this, back to this website. Let's see, here we go. sum to product. And the first one I had written down here was sine 7x plus sine 3x. So I'm going to use the first one, which comes out to 2 sine x plus y over 2 cosine x minus y over 2. And again, you may want to have your book line right next to you. All right, let's see. This is going to be 2 sine of 7x plus 3x divided by 2, 5x, times cosine of 7x minus 3x divided by 2, so 4x divided by 2, which is 2x. Okay. And the last one here is cosine minus cosine, and that comes out to negative 2 sine alpha plus beta over 2 sine alpha minus beta over 2. So I'm going to have a negative 2. I like to have a nicer looking negative. Negative 2. Sine a plus b over 2. So 5x plus 3x over 2 is 4x. And that's going to be sine a minus b over 2. So 5x minus 3x is 2x over 2 is simply x. And with that one, we're done with the problem section for the additional identities.